You asked me if an ordinary person, by studying hard, would get to be able to imagine these things. Like I imagine, of course, I was an ordinary person who studied hard. There's no miracle, people. It just happens. They got interested in this thing and they learned all this stuff. They're just people. There's no talent. A special miracle ability to understand quantum mechanics or miracle ability to imagine electromagnetic fields that comes without practice and reading and learning and study. So if you say you take an ordinary person who's willing to devote a great deal of time and study and work and thinking and mathematics and timeline, then he's become a scientist. The great difference in what goes on in the head when people think they're doing the same thing. And so it struck me, therefore, if that's already true at the most elementary level, that when we learn the mathematics and the muscle functions and the exponentials and the electric fields and all these things, that the imagery and method by which we're storing it all and the way we think about it could be it really, if we could get into each other's heads, entirely different. And in fact, why somebody sometimes has a great deal of difficulty understanding a point which you see is obvious and vice versa. It may be because it's a little hard to translate what you just said into his particular framework and so on. Now I'm talking like a psychologist that, I know nothing about this. Little things behave very differently than anything that was big, anything that you're familiar with because you see as the animal evolves and so on. His brain evolves, it gets used to handling. The brain is designed for ordinary circumstances, but if the gut particles in the deep inner workings were by some other rules and some other character, they behave differently, they were very different than anything on a large scale, then there would be some kind of difficulty in our understanding and imagining reality. And that difficulty we are in the behavior of things on a small scale is so fantastic. It's so wonderfully different, so marvelously different than anything that behaves on a large scale. Say, electrons act like waves. No, they don't exactly. They act like particles. No, they don't exactly. They act like a kind of a fog around the nucleus. No, they don't exactly. And if you would like to get a clear, sharp picture of an animal so that you can tell exactly how it's going to behave correctly, I have a good image. In other words, a really good image of reality. I don't know how to do it because that image has to be mathematical. We have a mathematical expression. Strange mathematics. I don't understand how it is, but we can write mathematical expressions and calculate what the thing is going to do without actually being able to picture it. It would be something like a computer that you put certain numbers in, and you have the formula for at what time the car will arrive at different destinations, and the thing does the arithmetic to figure out what time the car arrives at the different destinations, but cannot picture the car. It's just doing the arithmetic. So we know how to do the arithmetic, but we cannot picture the car. No, it's not 100%, because for certain approximate situations, a certain kind of approximate picture works. That is simply a fog around the nucleus, that when you squeeze it, it repels you, is very good for understanding the stiffness of material, that it's a wave, which does this and that, is very good for some other phenomena. All right, so when you're working with certain particular aspects of the behavior of atoms, for instance, when I was talking about temperature and so forth, that they're just little balls is good enough and it gives a very nice picture of temperature. Is it possible then to develop a familiarity with those things that are not familiar on hand by study, by learning about the properties of atoms and quantum mechanics, by practicing with the equations, until it becomes a kind of second nature? Just like a second nature to know that if two balls came toward each other, they'd smash into bits. You don't say the two balls when they come toward each other turn blue. You know what they do. So the question is whether you could get to know what things do without better than we do today. As the generations develop, will they invent ways of teaching and where, so that the new people will learn tricky ways of looking at things and be so trained, so well trained, that they won't have our troubles with the atom.